So in 4.5, we are doing more graphing. So we're kind of solidifying what we've already learned, but I'm going to teach you 3 new graphs. No, I lied, 4 new graphs, okay? And that's why your unit circle is out to start, because we're going to use that to help us make these graphs, okay? And primarily, we're only going to really use them for tangent. The other ones will have other ways of figuring those out. You will later. You don't write the second because there's not a lot of math to do. Can you remind me with my unit circle? Tangent is what in terms of x and y? Y over x. So what we're going to do is we're going to graph all of my y over x's for the 5 points that we have been graphing. We care about 0, we care about pi over 2, we care about pi, 3 pi over 2, and 2 pi. So when you look at your unit circle, your point for 0 is 1, 0, correct? When I do my y divided by x, what does that give me? 0, right? If for my 0-degree angle or 0 radian angle, your ordered pair is 1, 0. So when we do 0 over 1, we get 0. So I'm going to graph 0 at that point. Tangent of 0 is 0. When I do my 90 or my pi over 2-degree angle, that point now is 0, 1, correct? So when I do my tangent of that, y divided by x, what is 1 over 0? Undefined. Do you know how I show undefined on my graph? Not quite. We're going to do a vertical asymptote.
Oh,
Which makes sense, right? Well, remember when we did our rational functions earlier this year, like the C curve and the C curve, the vertical asymptote was where my denominator was 0. So vertical asymptote. All right, what about at pi? What's my ordered pair at pi?
will it always be vertical?
Yes. What's my ordered pair at pi? -1, 0. And so what would my tangent of that be? 0. Good. What about at 3 pi over 2? What would my ordered pair be? Good. And when I do my tan of 0, -1, what would that be? Undefined again. So I'm going to have another vertical asymptote. And then what's my ordered pair at 2 pi? 1, 0. So my tangent there would be 0.
Is this one of the ones where
There's only going to be one graph. You're going to see it in 1 second. But there's like, between all the vertical asymptotes, there's a bunch of parts, right? Okay, now I want you to remind me, all students take calculus. In quadrant 1, is tangent positive or negative?
Positive.
Positive. So I'm going to draw my line on the positive side of my graph. What about in quadrant 2, between 90 and 180, or between pi over 2 and pi? Is tangent positive or negative in quadrant 2? Negative. So I need to make sure that my line for tangent down here is underneath my x-axis. It's in the negative part of my graph. What about in quadrant 3, between 180 and 270? It's positive, so it's going to be up here. What about in quadrant 4? What's tangent going to be? Negative, so it's going to be down here. What's happening here with these tangents is it looks like a bunch of little cubic functions, doesn't it? A bunch of those little cubic graphs. We could keep extending this graph and it would take the same pattern on the other side. Now, do you notice that at the pi over 2 and at 3 pi over 2, we have our vertical asymptotes? Same thing if you're at positive or negative. If I'm at negative pi over 2 or negative 3 pi over 2, it's still vertical asymptotes. Do you notice at 0, at pi, and 2 pi, it's all through my x-axis, it's all a 0? Same thing at negative pi and negative 2 pi. And then my graph would continue the same way. It was going upwards, so that's downwards. I've got another little cubic function, and then I've got the first part of a cubic function. It only takes pi units to do a whole tan function, right? Because once we hit pi, then we're repeating ourselves. Okay, so a couple things to note here is tangent only has a period of pi. Sine and cosine both take a total of 360 degrees or 2 pi radians to do the whole pattern. Tangent repeats as soon as you've done 1 pi. Because then if I do this pattern, that's the exact same thing as what I have highlighted there. It's a new cycle. Here it is only pi. My vertical asymptotes are happening at my pi over 2s. If I were to continue, it would be at 5 pi over 2, at 7 pi over 2, at 9 pi over 2. And I have zeros at all of my whole pi's. So at pi, at 2 pi, at negative pi, at negative 2 pi.
How do we like find the X and Y? How to pi?
We just did that.
I know, but like how?
I looked at your unit circle.
Oh,
Remember? And I did the x and the y divided by x. Yeah. Same idea for cotangent. We're going to do the same thing. So we just looked at our unit circle. There's only so much work I can show when the answers are all 0 and undefined, right? At cotangent, it's the same idea, but now it's x over y. Okay, we're going to do the exact same points. We kind of should have an idea because we were just dealing with those points, right? At 0 radians or 0 degrees, what's my ordered pair again? 1, 0. So now I'm going to do x divided by y. So what's my cotangent at 0? Undefined. So what do I draw when I have an undefined? Vertical asymptote. There we go. What's my ordered pair at pi over 2? 0, 1, right? So now I'm going to do x divided by y. So what's my cotangent here? 0, because it will be 0 over 1. So that means I'm now going to have a 0 at pi over 2. Can you already guess what you think is going to happen at pi? Going to be a vertical asymptote, which makes sense because when I do my ordered pair at pi, it goes -1, 0, and x, -1 divided by 0, y, is undefined. What about at 3 pi over 2? What's that going to be? 0. And then what about at 2 pi? What am I going to have? Another asymptote. Very good. Now, this one looks backwards from the normal tangent, but it's going to make sense why it's backward. It's still all students take calculus, okay? So in quadrant 1, between 0 and pi over 2, tangent is positive, right? So I need to be above the x-axis. In quadrant 2, tangent is negative, so I have to be below the x-axis again. So now they're kind of like flipped cubic functions. In quadrant 3, am I going to be above the x-axis or below the x-axis? Above, because it's positive. And then what about in quadrant 4? Below.
Could it ever be like
The other way?
opposite?
It would have to be a negative cotangent then. So normal cotangent looks like this.
So whatever the first one is, if one is negative, then it's opposite.
And then I could extend this back the other way. I would have a vertical asymptote at -2 pi and negative pi, and then I would just kind of get my little negative cubic functions all the way down as I was doing earlier. We're not going to do a lot of graphing tangent and cotangent because they don't get super interesting. We're going to focus more on the secant and cosecant in a second. But I wanted to show these. And I also promise on the test, I'm going to have 4 pictures of these, and you're going to have to tell me which one's which. So you just need to be able to recognize which one's cotangent, which one's tangent, which kind of sounds scary, but I promise it's pretty easy if you just spend 2 more seconds looking at it. In order to help me with that, remind me, where are my vertical asymptotes on my cotangent? Those are happening at 0 and pi and 2 pi. So I'm just going to say at my whole number of pi's because my zeros are happening at my 1. My fractions, my pi over 2s. Okay. The next one we're going to do is cosecant. And the reason we're going to do cosecant next is because it goes with sine, correct? You guys all remember that that goes with sine? In order to graph this one, we're going to actually graph sine first, and then from there, I'll show you the adjustments, okay? So you guys remember sine. We should be able to graph that in our sleep at this point. We know sine starts in the middle, goes up to the highest, goes back to the middle, goes to the lowest, and goes back to the middle. You guys all okay with me that being sine? Yeah, I don't need to explain that more, right? I am going to go back in the other direction though, just so I have a fully complete graph. So I would have gone down, middle, up, middle again, just to make sure that sine graph is the same and keeps on doing its little wavy thing. Okay. Now, cosecant goes with sine, and remember that it's the reciprocal of sine. So cosecant is the same thing as 1 over sine or 1 over y. Instead of my point at 0 in my cosecant graph being 0, it's going to be 1 over 0. What would that happen then? It would be undefined, so that means I would have a vertical asymptote. So when I have cosecant, every time I'm at the 0 or in the x-axis, I have a vertical asymptote. So where else do I have vertical asymptotes besides 0? Pi and good. And then the negatives, right? Negative pi, negative 2 pi. Now, the only other points we have are 1. So at pi over 2, it would be 1 over 1, which means that it's the exact same point. But then it's not going to be going down the way it was in the original picture. It's going to go in the opposite direction. So it's going to go up and away from the x-axis. At 3 pi over 2, it's still going to go through negative 1, but it's going to go down and away from the x-axis. My cosecant and also my secant, you'll see in a second, is essentially a parade of parabolas up and down across the page. I'll do it over here too. That negative 1 just goes away from the x-axis. That positive 1 parabolas away from the x-axis. Now, I generally draw my picture and I always have my sine or my cosine showing. If you don't want to graph that, you don't have to. This is what your graph would look like if all you had were your cosecant points. You see parabola, 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 parabola. I do like having my sine so I can prove why it's there. And the sine is doing the kind of like shifting and going up and down and expanding around for it. Just like the one above it, and I was pretty intentional with this, and this one also has a vertical asymptote at all the pi's. That's why I have cotangent and cosecant with each other for you to kind of see some patterns with each other. I'm not going to write zeros here because there's no actual like 0. They're all parabolas on the other parts. And then notice here that these do have periods of 2 pi, just like sine and cosine do. Okay. So we're going to do the exact same thing, but for secant, we're going to graph cosine, and we'll put the vertical asymptotes, and we'll put our parabolas up and down as needed, okay? So why don't you jump over to the one next to it? Let's go graph those secants. And that means we're doing cosine. So I'm just going to graph my normal cosine. I know what all my angles are. 0, pi over 2, pi, 3 pi over 2, 2 pi. I know I start high, medium, low, medium, high. And I can also go back in the opposite direction too. So that's my general cosecant graph. But again, we're not just doing cosecant, we're doing 1 over, all my x's are 1 over cosecant. And it's the exact same rules as what we did before. If it's on the x-axis, if it's a current 0, it's going to become a vertical asymptote. And then if it was 1 or negative 1, it's going to become a parabola going away from the x-axis. 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 And again, we're happy to not graph that cosine if you just want to see the little parabolas up and down. It's basically the exact same thing as cosecant. However, it's just shifted over a little bit. My period is still 2 pi, and it's vertical asymptotes now are on my pi over 2s. Versus cosecant has them on the whole numbers. Yes, Nikki, are you sure? Okay. We're gonna go do 4 graphs of these, and again, I said that we're focusing on the secant and the cosecant. This is almost the same as what we were doing yesterday, but just we're not gonna be done when we graph sine and cosine. We'll have to go one tiny step farther to get to cosecant or get to secant. Okay, we're gonna skip these 2 tangent and cotangents because those are not nearly as interesting. We're gonna come down to the cosecant down here on letter G. You guys ready to join me down there? I know you might not be, but we're gonna do it together, okay? I, again, am not using these graphs. I'm gonna draw my own graph. And I'm gonna start by labeling all my pieces. What's my amplitude for this one gonna be? 3, good. And what does that negative do to my graph? Flips it. What's my period gonna be here? It's gonna be 2 pi divided by 1/2. And what's 2 pi divided by 1/2? The same thing as 4 pi. Good, 4 pi. And then my period shift, my phase shift, excuse me. Remember, that's where we just set the parentheses equal to 0. In this one, there's not a lot of work to be done because you just add that pi over 3 to both sides, so then we can see easily it's right pi over 3. Okay. While we're thinking about it, how do I figure out the distance between each tick mark? Do you remember what we do to find out the distance between each tick? Good. 4 pi divided by 4. The period divided by 4. So 4 pi divided by 4 means that I'm going to be adding pi each time to the angle that I have to get to the next angle. Okay, so before I do that, let me start setting up my picture. I've got to deal with my amplitude. So I'm up as high as 3. I'm down as low as -3. And I'm starting right pi over 3 units. I know I have 5 important points. So I've got 2, 3, 4, 5 tick marks out there. And then if you like your grid, you don't have to draw it. I like to draw it. So I'm going to draw my grid where I'm starting, where I'm ending, my left or the top and the bottom. Yes, Jonathan.
When you said on the test, we draw our own grid, right?
Yep, I'm going to just have no graph on there
It's a
for you.
blank spot.
Yeah, it's just my big blank spot. Yeah, I think that's easier than having to fit it on a graph already. So, okay, and then now I'm gonna add pi to pi over 3 as many times as I need to get my next angle. So I'm gonna get my calculator out. You can do this by hand, and this one's not a hard one. But if you're like panicked by it already, just put it right in your calculator. 1/3 plus 1. The only thing I'm going to tell you is don't put pi in the calculator if you want to do this. It's going to make it a lot messier. You're not going to get your fractions. Just remember to add pi when you put in your fraction. So I'll start with 4 pi over 3. Then I'll add 1 to that again. I'll add another pi to that. Make it a fraction. 7 pi over 3. Add another 1 to that. Make it a fraction. 10 pi over 3, and then last one, add another 1 to that, make it a fraction, 13 pi over 3. We have our graph all set up. Now tell me, cosecant is what? Sine or cosine? Sine. Very good. So we're going to graph sine to start. I'm going to graph a sine, and then from there, I'll do my vertical asymptotes and my little parabolas. So I'm going to start in the middle, go high. Oh, nope, not go high. I'm going to go low. Why am I going low? Flipped. Very good. Middle. Now I get to go high, and now back to the middle. You don't have to draw your actual sine curve if you don't want to. I like it, so I'm going to. You don't have to, because now that I have the points, now I know where my vertical asymptotes are. They're the ones on the x-axis. So right here, let me make that a bigger guy. At pi over 3, at 7 pi over 3, and at 13 pi over 3. And then my parabola is going to be at 4 pi over 3 and at 10 pi over 3. And so if it makes you happy to not have that sine curve and just those two parabolas, go for it. I like to show it just so that I can kind of prove that I did my sine graph. So basically everything we're talking about is the same as what we did yesterday. We just have one tiny step at the end, right? Do you think we can try the next one? Oh, Francis, question? So the PS is your parentheses equal to 0. And that tells you if you're moving right or left and how much. From that point, though, then you do your period divided by 4 to say, I'm going to add whatever to that pi over 3 to get to the next angle. And so that's, you're always doing, this is your period divided by 4 is your distance between the ticks. Don't put pi in the calculator. Just make it a fraction without pi. All right, let's jump to the next one. Go ahead and start. Figure out what your amplitude is, your period, your phase shift, all that fun stuff. Are you well done?
Yeah.
Can I write your class?
What?
Oh no, this is harder. Can you just write your class anyway? I don't know what you have to.
What's the page?
I just said that. Parentheses equals 0. Say your parentheses equal to 0. Give me 1 second. I'll join you guys in a moment. Okay, I have my amplitude, I've got my period, I've got my phase shift. I have my graph set up without having done my angles yet. So I've kind of got everything that I believe you guys should be able to do pretty easy. I see some of you have been calculating your angles already, which is awesome. Does anybody have any questions on what I've done so far? Okay. Now, in order to know what I'm adding to my angles is I have to do my period divided by 4. So I'm just going to add 1/4 to all my angles, or pi over 4 to all my angles to get to the next angle. We're starting at -1 divided by 8. I'm going to add 1/4 to that. make it a fraction. I get 1/8 or pi over 8. I'm gonna add 1/4 to that. Make it a fraction, I get 3 pi over 8. I'm gonna add 1/4 to that. Make it a fraction, 5 pi over 8. And then add 1 more fourth. Make it a fraction, and I get 7 pi over 8. I have all my pieces labeled, my x-axis, my y-axis. When I graph, am I going to graph a cosine or a sine graph? Cosine, very good. So we're going to graph that cosine graph first, and then from there we'll graph our secant. So it's a normal cosine, so I start high. Once I've done that, now I know where my vertical asymptotes are. They're at my x-axis. They're at pi over 8 and 5 pi over 8. And then my parabolas are at 3 pi over 8. At half of it's at 7 pi over 8, and the other half is at negative pi over 8. Now, if you don't like those half parabolas, you can do the whole parabola. That's fine with me. But technically, you don't need it the way that secant is done. The way that it is set up, you don't need the whole because you have the other half of it. Yeah, Nikki.
So. They're always, all the graphs are always the same. It's always the same way.
Like setup?
Yeah.
Yes. So Nikki's asking, you do altitude, the period, the phase shift, and the vertical shift the same, no matter what trig function is graphed. And then that last step is which 5 points do you graph, right? Is it the sine ones or the cosine ones? And then if you need to go a step further from cosine to make it a secant. All right, I think there's 2 more like it on the backside, so we're going to jump back there, and we're going to do those 2. I really have just 5 more problems I want to do today, so I'm going to pause for a second. I want you to start letter I without me. The only thing that's different here is it also has a vertical shift, so make sure that we take that into consideration. A vertical shift. I've got my amplitude, my period, my phase shift, my vertical shift. I've got every part of my graph labeled except for my angles. Double check where you're at. Questions do we have? You guys okay so far? Okay. All right, now my question is this a sine or a cosine graph? Cosine, very good. So we're going to graph cosine, and then once we've graphed cosine, then we can go through and do our secant part of it. So I'm going to graph my normal cosine. Oh shoot, I didn't do my angles yet, did I? I'm so sorry. Let me do my angles first. What am I adding to each of them? Pi, good. So we did 4 pi divided by 4, we get pi. So I'm going to add 1/6 plus 1, 7/6. And then is it 13/6? Then 19/6 and 25/6. That's what you guys got? All right, then I'll do my points. I'm so sorry for skipping that step. I'm sorry, I skipped the angles, but once you got your angles, then you graph your 5 points. And then once you graph your 5 points, we know it's secant, so we've got to do a tiny bit more. I no longer have points on the x-axis, but the points that are in the so-called middle of your graph, so at 7 pi over 6 and at 19 pi over 6, those are now my vertical asymptotes. You guys okay with that? And then the other points are where my either whole or half a parabola come from. All right, we got one more like this. Go ahead, jump onto letter J if you're ready to start without me. Now, you got for your phase shift, right, a right 3 pi over 5, correct? That's kind of weird. We haven't gotten a number like that, but does that really stress me out? No, because I'm just going to use my calculator. What am I going to add to that 3 pi over 5 to find my next angle? Not 1. Do your period divided by 4. I think it's 3 halves, right? Do you guys get 6 pi as your period? Yeah, so then when I do 6 pi divided by 4, I get 3 pi over 2. So my distance between each tick mark is going to be that 3 pi over 2. And so even though it's messy, it's okay because I have my best friend, the calculator. 3 divided by 5 plus 3 over 2. Make it a fraction. Oh, I have an add. You keep it rolling. I'll catch up in a minute. One pi over 10 plus 3 halves. 18 pi over 5 plus 3 halves. 51 pi over 10 plus 3 halves, last one. 33 pi over 5. This one is cosecant, so that means that we're doing our sine graph. So we'll graph our normal sine curve. And then from there, we'll remember that we're not stopping at sine, we gotta do our cosecant. So at the middle points, we get a vertical asymptote. And at the highest and lowest points, we get parabolas. The reason I like doing this part of the chapter is because it helps just really solidify the graphing. So today we just did even 4 more graphing problems like what we did the last 2 or 3 days. Like we've been doing a lot of this practice. So this is something that if you are having a hard time with still, you got to come see me. If not, I hope we've done enough problems that you feel more confident. The last 3 problems are a little bit different. And they are they are not graphing calculator, they're unit circle problems. So if you want to just make sure your unit circle is back at the top, we just have 3 more quick problems and then we'll work on homework for the rest of class. I got it. So we'll do those last 3 really quick. So these, you've done ones like this before. It's like we've hit it like 2 or 3 times. So I'm just bringing them back up to our attention. And I think letter C is actually the easiest one. So join me on number 2, letter C. It says tan of x equals 1. Okay. This is us using our unit circle. Remind me, tan is what over what? Good. Tan is y over x. And what angle will give me a y divided by x that equals 1? What angle has an ordered pair of y and x that when divided, then it'll give me 1? 45. Very good, Mare. You know it's going to be the exact same point. It has to be the same x and same y, and the only one that we have like that is 45. Now, 45 does give me a positive tangent, so 45 is one of my answers. What's my other answer? Where else, what other quadrant would have a positive tangent value? Quadrant 3, and what's my 45-degree angle in quadrant 3?
Negative square root.
Good, but it's
220.
225. What would my radians for both of those be? What's my radian of 45 degrees? Pi over
4.
4. And then what would it be in the third quadrant? 5 pi over. Good. And see, there's not even really a lot of work here. You don't even need to write that down. You don't even have to write that down. You could just write down the angle. The next 2, you might want to do a little bit more work, but we just kind of spotted and we found it. Okay. Let's go to letter A. I think that's the second easiest one. This one says secant of x equals 2. Okay, wait. Secant is not one of my main trig functions. Which one is that a reciprocal of? Cosine, good. So that's the same thing as saying 1 over cosine equals 2. Well, we're not used to doing 1 over cosine. We're just used to doing regular cosine. So if I flip 1 over cosine to just be normal cosine, what would the right side of my equation flip to be? 1/2. Ooh. Cosine is which variable, x or y? Could you find which angle has a cosine or an x of 1/2? 60 degrees. Where else would cosine be positive? Which other 60 degree? In quadrant 1, 2, 3, or 4? 4. And what would your 60-degree angle in quadrant 4 be? 300. Basically, you're doing 360 minus 6. And then just so we're kind of getting all of our brains connected, what's my radian for 60 and what's my radian for 300? Pi over 3 and good. The 11 goes with the 6. 5 goes with the 3. All right, I skipped one. We got one more we're going to go back to. Am I moving too fast? Or are you guys hanging with me? Doing okay? Okay. Again, we've done this before. We're just kind of doing it again. It's a little out of order, but it's okay. This next one says cotangent of x equals negative root 3. This one, I think it's easiest to just go right to your x, y. Cotangent is what in terms of your x and y? X over y. So we want an ordered pair. That's when you do x divided by y, you get negative root 3. Okay. In my head, there's only two options. What's one of those two options? Could it be 45? No. Could it be 0 or 90 or one of my other quadrant angles? No. So my other two options are my 30-degree angle or my 60-degree angle. Do you remember what my ordered pair for 30 is? It's the other one. This one starts root 3. And then 60 starts. So it's got to be one of those. Which one do I need? If I do x divided by y, which one needs to be on top for us to get just root 3? Square root 3. Good. And you could try this out. You could do, like, I might have to write square root 3 over 2 over 1/2, and then I'd have to multiply by my reciprocal and be like, okay, that's how I get just root 3, no denominator. That means that I want the one where x is root 3 over 2 and y is 1/2. So that means I want my 30-degree angles. However, this cotangent is negative. So which quadrants do I want to get my 30-degree angles from? Good, 2 and 4. What is my 30-degree angle in quadrant 2? 150. While we're there, what's the radian value for that? 5 pi over 6. And then what would your quadrant 4 30-degree angle be?
330.
330. And what would that radian be? 11 pi over 6. We are not going to do any of those with the calculator, so we're not going to worry about those.
Is that on the test?
No. What we just did could be on the test. The calculator ones are not on the test.
Just the graph.
Just the ones we just did with the unit circle. Okay, when you go to your homework, I want you to change a couple things on it. I know I already did my homework, so I went it all up on, or I did some of it. On number 1A, can you make it say cosecant, not, is it a cotangent or tangent? Those are not as interesting as cosecant and secant, so I want you to make that cosecant for 1A on your homework. Make 1A on your homework say cosecant. And then on number 3 on your homework, the last one, I want it to be 5 cotangent x equals 5. I don't want it to be equal to 7 because I want it to be something that you can see on your unit circle. I want it to be 5 cotangent x equals 5. I'm sorry for not doing that on my end. The last two problems on the homework were like those last 3 we just did. The first 2 are all the graphings like we did earlier, okay? I don't see you guys tomorrow. I see you on Thursday for review for the test. That won't be until Monday, but I'm going to give you the review. We're going to spend time reviewing tomorrow in class, Thursday in class. Okay. We have about 6 more minutes. I'll be quiet. I'm going to do this last problem on my homework, so I have a key ready. And that's all I've got. Anybody need anything from me? Got homework from me? Yeah, thanks.
Sorry, we were driving.
That's okay. No worries.